Hey guys, in this video we are going to solve a very specific but important problem in fuzzy set theory. How to check whether one fuzzy set is a subset of another. Now, if you're thinking this works like classical sets, you're way off track. In fuzzy logic, subset verification is not about element presence, it's about membership dominance. So formally a fuzzy set A is a subset of B if and only if for every element X in the universe, the membership value of A is less than or equal to that of B. So instead of checking inclusion, we perform an element wise comparison. And what I'll do in this video is break this down into a clean arithmetic analysis and then map that logic directly into a Python implementation using class-based approach. So before we jump into the code, I would like to first recommend you check the previous videos where I have entered the fuzzy set A and set B and how I entered them using create fuzzy dictionary method, right? And this entire program is just basically of two simple segments. One is a class and one is a main method. And that inside the main method, we create fs1, an object of an instance of the class inclusion set, and on creating this fs1 object we have basically invoked this default constructor fuzzy dictionary and initialized it as an empty dictionary, right? And thereon for each set we have called a loop. We are running a loop inside this set A, and for each number of times we have entered an element, that is, say if the number of elements is 4, we have called create fuzzy dictionary. So we do that for set A and for set B, and on creating both the dictionaries we have printed it out, and then when we have both the dictionaries we are using the first object, that is set A, and the second object, set B, and passing the set B object as a parameter to check inclusion method. Now what happens inside check inclusion method? Since we are passing the second set, that is it is received in other, which is other set, and other set is basically an object of an instance of type inclusion set, an instance of the class inclusion set, right? So this method check inclusion returns a boolean value, and inside this method in line 48 we have a loop running through only set A, and we are not running a loop through set B because set B right here is used as this dictionary set B, or dictionary B rather, is being used as a lookup table. So on accessing the key and value which we get using the items method of the dictionary, we check if the A key on the first iteration, which is x1, is not in other fuzzy dictionary. So if x1 is not present in the other fuzzy dictionary, which is dictionary B, then we return false. So that means that x1 has to be present in the other set, that is set B, for it to be able to be a subset of that other set. So if it is not a part of that other set, if x1 is not present in other set, then we'll just return false, because in that case it will never be a subset of the other set of set B. So in line 52 we check that we don't check, we have other dot fuzzy dictionary. That means we are getting the membership value of the other dictionary and we are setting it to B value. So since we have 0.4 here as B value, now we make the difference, that is 0.4 minus 0.3 for the first iteration, and we put it into difference reference variable. Now in this case for the first iteration, 0.4 minus 0.3, that is we get 0.1, a positive integer. Now we check if that difference, which is 0.1, if it is less than 0 or not. Now since 0.1 is greater than 0, it will come out of this if statement, if condition, and it will return true. If it is less than 0, it will return false. Now for such cases, for such iterations, in case the difference is less than 0, it shows that that set is not a subset or an inclusion set of the other subset, other fuzzy set, right? So when we have returned true for it to show that it is a subset or not, or return false for that matter, we receive it in is subset. So is subset is of type boolean, and we check, there are two ways to check if the subset is true, which is commented out right here. Then we print that A is a subset. If it is not true, or if it is false, then it is not a subset of B, or we just print it in one single line using the formatted string method, right? Formatted string way. um, so I'll just run this using Python 3 inclusion. I'll give it, say, 3 elements for each set. A will be 0.8, B will be 0.7, C is, say, 0.2, and fuzzy set B, right? So fuzzy set B has to have the same elements. Now say if I give an incorrect element, it will say that it is not a subset of B, that A is not a subset of B. So best I give the same elements, and for B element I give 0. No, it'll be the same. Okay, even if it is the same, it is still a subset of. And for C I give 0.1. Now A is not a subset of B, right? Because 0.5, as we have calculated here, B value minus A value, 0.5 minus 0.8 is a negative value, but it tells us here that if it is less than 0, then it is not a subset. So it is not a subset. Now I'll ensure that I'm giving it just 2 elements, making it easy, that I get a positive integer right here, the difference, just to make sure that I get a subset. 0.8, give it any value. Now 0.9, right? So in set A, in set B, element A, I have to give 1 so that it is a positive, and for B I'll give, say, 0.9. so A is a subset of B. Why? Because 1 minus 0.9 is 0.1, and 0.9 minus 0.8 is 0.1 also. So that is the reason why it is not less than 0, where each membership value is not less than 0. So it is A is a subset of B. So to wrap this up, fuzzy subset checking is all about comparing membership values, not elements. If mu A, that is set A, is less than or equal to set B for every element, A is a subset of B. One violation and the condition fails, like we have seen here. So that's the entire logic, simple but critical in fuzzy systems. If this clarified the concept, apply it to other fuzzy operations and you'll start seeing the bigger picture. So if you have any questions, let me know in the comments below, and I'll see you on the next one.